Let's continue our discussion about Euclidean distance, that is dissimilarity calculation. We had already seen this formula. Let's continue with solving the problem using Euclidean distance. Okay, yes, this is our formula. See, our formula was d of xy is equal to xk minus yk whole to the power r, and the square root for this, okay, and the square root, whole square root. So that was our formulas, which can also be rewritten in this way, where r, okay, r here, we have to substitute r is equal to 2 for calculating the Euclidean distance. Having distance, we have to substitute r is equal to 1, whereas when r is equal to infinity, it becomes the supremum distance. So as we already know this formula, let's continue solving the problem. Okay, see here, we are rewriting this formula something like this. So how are we rewriting the formula? Just to see over here. Okay, see this data set. First of all, the problem is to find the Euclidean distance for the given data set, and you can see here the data set is something like this. X coordinate list is given, y coordinate list is given, and this is information about 4 points, P1, P2, P3 and P4. The coordinates of P1 is, X coordinate is 0 and y coordinate is 2, P2 2 and 0, P3 3 and 1, and finally P4 is 5 and 1. You can also call this as X1, Y1, the coordinates of P1, x2, y2 coordinates of P2, x3, y3 coordinates of P3, and x4, y4 coordinates of P4. This is something which is similar to the graph that I had shown you all. I hope you all remember this graph. Yes, can you all see this graph? Yes, this is the graph where these are the 4 points, and the data set what I am showing over here is the same information. Okay, and the formula of Euclidean distance is this. I hope you all remember, where we have taken the square root and go to the power square. Okay, yes, let's continue solving the problem. See, this is our formula. Now, as I already said, we have to rewrite this formula. What is this rewriting? How do we find the distance between any 2 points? How do we find the distance between any 2 points here? See, the P1 and P2 are the 2 points here. How do you find the distance between them? When we need to subtract P2 from P1. So how do we subtract P2 from P1? That is nothing but we have to subtract the x coordinates first, and then we have to subtract their y coordinates. Okay, so as per the formula, it is xk minus yk the whole square in general, but in reality, when we have to find the distance between 2 points, we have to subtract the x coordinates first. So that is x2 minus x1 the whole square plus, it is sigma here, that is y, plus y2 minus, that is the corresponding y coordinates also have to subtract, y2 minus y1 the whole square. Then the answer, the sum of their squares should be taken the square root of the sum of their squares. Okay, so let's go to the formula, let's go to the problem there. So the formula is this, what you all can see. Now let's substitute here x as x2 minus x1 the whole square. So let's take the point 1, that is x1 is here, point 2 here is, x coordinate of point 2 is 2. So x1 is 0, x2 is 2. So x2 minus x1 the whole square, if I have to find the distance between P1 and P2, first subtract their x coordinates, that is 2 minus 0 the whole square, plus, since this is sigma, plus y2 minus y1 the whole square, y2 here is 0, 0 minus 2 the whole square. So the square root of that is actually the distance between the 2 points P2 and P1. So that becomes our Euclidean distance between the 2 points. So you can see how we have solved it. Okay, just see. The formula is rewritten as x1 minus x2 or x2 minus x1. It's one and the same. x1 minus x2 the whole square plus y1 minus y2 the whole square. So here you can see 0 and 2 are the corresponding x coordinates, 0, 2 again they are the corresponding y coordinates. You take the square of those two, add their squares, and then the square root of that is given here. I was saying about this here. It's the next part. Okay, so we get the square root of 8. So 2 square plus 2 square, that is 4 plus 4, 8. Square root of 8 is equal to 2.8. That is the distance between the 2 points P1 and P2. And here the first part of that, as you all can see, here it is the distance between the same point, that is the distance between point P1 to itself. So I hope you all know what is the distance between point to itself. It is always 0. So you can see the point 0, 2, the distance between itself 0, 2. So when you take the square root of their sum of squares, that is 0 minus 0 the whole square plus 2 minus 2 the whole square, and the answer becomes again 0, that is distance is 0. Okay, similarly now you continue calculating the distance between all the points. Okay, so how do you continue? So here we have just now calculated the Euclidean distance between the point P1 to itself and then P1 to P2, and now you continue distance calculation from P1 to P3 and then P1 to P4. Okay, similarly you continue your calculation, Euclidean distance to continue calculation, that is from P2 to P3 and then P2 to P4, and finally P3 to P4 you calculate the Euclidean distance. Then Euclidean distance. And now you just see here whether the Euclidean distance between P3, P4 and the distance between P4 and P3, is it the same? It is something like the distance between, you can see here in the graph, the distance between P3 and P4 as well as the distance between P4 and P3, is it one and the same? Yes, it is one and the same. Right, and we call this property as symmetry property. Similarly, P2, P3 or P1, P2. So everywhere it is symmetric. Why is it symmetric? Because the distance between P1 to P2 or the distance between P2 to P1, it is one and the same. Okay, right. So I hope it is clear about the Euclidean distance. You can see the calculations over here. We have calculated the distance between points P1 and P2. Similarly, calculated the distance between P1 and P3. Here you can see the point P1 is given by 0, 2 and the point P3, the coordinate is 3, 1. Can you all see there in the data set? P1 is 0, 2, x coordinate and y coordinate. P1 is x 0, 2, that is x and y coordinate. P3 is 3, 1, that is x and y coordinate, x3 and y3. Now when we calculate the Euclidean distance between P1 and P3, it becomes x3 minus x1 the whole square plus y3 minus y1 the whole square, that is 1 minus 2 the whole square, and their squares, whatever you get the answer, the sum, take the square root of that. Okay, that is the Euclidean distance between P1 and P3. Same thing you have to continue for P1 and P4 as well, whereas P1 is 0, 2, P4 is 5, 1. So x4 minus x1 the whole square plus y4 minus y1 the whole square, and then the square root of their sum should be taken, and that answer becomes the Euclidean distance. Okay, I hope it is clear. P1, P3 distance we have found, the answer is 3, 2. Then P1, P4 also distance we have found, the answer is 5.1. Similarly, you continue a calculation for distance between P2, P3, then P3, P4. Okay, right. So the final distances, whatever we have calculated, is shown here in this table. You can see here the table is written in the form of matrix, wherein you can see this 4 points. These are the 4 points, and here you can see along the rows we can see individual point along the rows. Along the columns also we have represented the individual points, and you can see this values, whatever you can see throughout the table, is the calculated Euclidean distance, right? So whatever you have calculated, it has been recorded in this table. So distance between P1 and P1, that is 0, and similarly you can see distance between P2 and P2 also is 0, P3 also is 0, distance between P4 to itself itself is again 0. So you can see this is a kind of a symmetric matrix where all diagonal elements are 0 and rest all other elements is filled up. Distance between P1 and P2 is 2.8. Right, and the distance between P2 and P1 also is 2.8. So is it not symmetric matrix? Yes, so it is symmetric. So P1 to P3 is 3.2. Point P3 to P2 is also, P1 to P3 is 3.2. Similarly, P1 to P3, yeah, there is one more. Yeah, that is P3 to P1 distance also is 3.2, right? So you can fill this table. Okay, so that is the Euclidean distance. Now let's continue calculation of Hamming distance. The formula remains the same, and I hope you all can you all remember what is Hamming distance. The formula remains the same. It is the other way of calculating. That's the other formula to calculate the Euclidean to calculate the distance or dissimilarity between the two objects. So here the two objects are x and y, or you can say the two objects are the 2 points, and the distance between them can be calculated using the formula, where here the formula remains the same as Euclidean distance, whereas this r value will be equal to, substituted as 1. So when r is equal to 1, you can say it is xk minus yk. That is the summation from k is equal to 1 to n. K refers to dimension here. It is 2-dimensional points, and xk minus yk here refers to the two objects, distance between the two objects. So here in the Hamming distance, you can say here r is substituted as 1. Now for the same above data set, you can calculate the Hamming distance. See how to calculate the Hamming distance. The data set remains the same, and the formula here is xk minus yk. Now when you subtract, remember you have to subtract first the x coordinates, that is x2 minus x1, then take the summation plus y2 minus y1, same as Euclidean distance, but the thing is here there is no square. You're not taking the square or square root of the sums. Okay, so here just you have to subtract the x coordinates first, then subtract the x coordinates first and then subtract y coordinates, then add up them. Then the answer what you get is the Hamming distance. Okay, now we'll just see first how to calculate the distance from point to itself, that is P1 to itself. So as we know, point P1, the coordinates is 0, 2, and then point P1, again the coordinates of the same point is 0, 2. Okay, so we can calculate the distance using Hamming distance formula. This is the way that we do it. Okay, so we can just see over here the 2 points over here are P1 to itself. So x1 minus x2 plus y1 minus y2. The only difference is here you don't have to take square as well as square root of the sum. Okay, so you can just see here. Yes, the distance between P1 and P2, that is the Hamming distance between P1 and P2, and P1 coordinates 0, 2, P2 coordinates is 2, 0. So x2 minus x1 or x1 minus x2 plus y1 minus y2, 0 minus 2 plus 2 minus 0 is nothing but 4. And here you can see whenever the negative sign, this is a determinant. Okay, the formula itself has this determinant. Anyways, you know that you will not have the negative values, so the sum is positive value, that is 4. Similarly, calculate the distance between all the points, all possibilities you calculate using Hamming distance, and finally this is the resultant table that you get. Okay, so this is again the skew symmetric matrix you have. Diagonal elements are 0. Okay. And now the third formula here is supremum distance. So supremum distance is r, the same formula where r you are substituting as infinity. Okay, so what is that formula, infinity? Okay, so the distance between the two objects x and y here you can calculate as maximum of x1 minus x2 and y1 minus y2. So this formula becomes still more simpler. Here you don't have to calculate the square, also you don't have to calculate the square root. Okay, so here you just have to find out the difference between the x coordinates as well as the difference between y coordinates, and then you find out the maximum out of them. Okay, that itself is the supremum distance. Now you can see the distance from point 1 to itself. So this is anyways self-explanatory. I don't have to explain. So see here the distance between 2 points now, P1 and P2. is P1 coordinate 0, 2, P1 coordinates is 0, 2, P2 coordinates is 2, 0. So x coordinates difference. So x1 minus x2 is 2. Determinant again negative. You please don't consider here value at all because the distance cannot be negative. That is why don't consider the negative value. Then 2. Yes, so you can calculate the maximum of 2, 2. Anyways, negative you don't have to consider. So directly the distance is 2. So now as usual you continue calculating the distance between multiple points, and the distance that is the distance between P1 and P3, P1 and P4. So you can see here the maximum value of this, that is P1 and P3. The distance between P1 and P3 you're calculating. x1 minus x2, y1 minus y2 separately you have calculated, and the maximum out of 3, 1. So it's not minus 3, so plus 3, 1, and then the maximum is 3. So this is the distance between P1 and P3. Okay, so now we are continuing with all these calculations. Finally you come up with this table. Again, this is a symmetric matrix. This looks like this is actually the symmetric matrix. All diagonal elements are 0, and then you can see here the distance is what you have calculated. Okay, so these are the 3 different formula to calculate the similarity. One is Euclidean distance, second one is Manhattan distance, and the last one is supremum distance. So this formula remains the same. Only thing is you have to substitute different values for r in the formula. Okay, I hope it is clear, and consider this is actually important exam point of view also. Yes, now we are done with the dissimilarity calculation. Now let's move on to similarity calculation. Okay, so as we have already discussed about similarity is nothing but we are just trying to find out in our data set if two objects, that is say x and y, whether those two objects are similar or not. We are not calculating any distance or difference or dissimilarity between the two objects. Here we are trying to find out how similar the object, whether the objects are very much closer to each other or whether they are very similar to each other. That is what we are trying to find out. Let's start with the binary data. So as you all know, what is binary data? All values are in zeros and ones, correct? Okay, so how to find out the similarity between the two objects whose values are binary values? Okay, we'll see that. Now you can see here, we'll take one example. Okay, so yes, right. So if I have two objects, say x and y, the two objects are, if the two objects x and y are very much similar, then I take the similarity value as 1. If the two objects x and y are not at all similar, that is completely different, then the similarity value will be equal to 0. So this is what you have to remember. Now for the calculation purpose, that is for the similarity calculation of two objects and whose objects has the attribute values, all binary values as its attribute values. Okay, in order to calculate the similarity, I take here 4 coefficients. So what are those 4 quantities or coefficients? So they are, you can see here, f00, f01, f10 and f11. These are the 4 coefficients that I take here to calculate the similarity between two objects which has binary values, right? So here what is f00? F00 indicates the similarity between the two objects where value of x is equal to 0 and value of y is equal to 0. So this in general I can write it as fxy. Here x represents 0 and here y represents again 0, value of x and y. Similarly, the other coefficient is, the second coefficient is f01. What is the meaning? fxy, x is equal to 0 and y is equal to 1. Similarly here, fxy, x is equal to 1 and y is equal to 0. And finally fxy, x is equal to 1 and y is equal to 1. So here you can see fxy, when it is equal to 0 and 0, this means that the two objects x and y has value 0. You can call this as similarity is absent here, absence of similarity, and you can call this F11 as presence of similarity. There is similarity, that is the indication of this, because 1 represents highly similar, high similar value, highly similar. I mean, when the two objects are tend to be highly similar, you say that the value of similarity is equal to 1. So F11 represents presence of similarity, F00 represents absence of similarity. Okay, right? So we will just try to calculate or compute a few problems here. Okay, so we will see few formulas to calculate the similarity, right? So let's start with the first formula, that is simple matching coefficient, in short SMC. We call it as SMC, and this formula, SMC formula, is mainly used for similarity calculation between the two objects, and most of all when the two objects has binary values only, right? So you can see the formula for SMC is number of matching attribute divided by number of attributes. So here number of matching attributes means what? See here, we could see the coefficients. We have 4 coefficients. We had 4 quantities, F00, F11, F01 and F10. In that matching attribute values means what? You could see here matching attribute. When x is equal to 0, y also is equal to 0. And here when x is equal to 1, y also is equal to 1. But what about these two? When x is equal to 0, y has the other value 1. Here when the x is equal to 1, y has the other value 0. So these two I cannot call them as matching coefficient, whereas the first one and the fourth one I would call them as matching coefficient. So here in our formula, that is SMC calculation, it says number of matching attribute values, that is F11 plus F00 divided by total number of attributes. So divided by number of attributes, how many quantities we have? Total 4. So all 4 quantities you take here, sum of them, that is F00 plus F01 plus F10 as well as F plus F11. So you can see the formula, F11 plus F00 represents number of matching attribute divided by number of attributes, all the 4. This is the formula to calculate SMC, and remember this is only when the two objects has binary values. Now we have the second formula to calculate the similarity, and that is Jacob coefficient. Okay, so what is Jacob coefficient? See, what was the drawback in SMC? You just see here. In SMC, we were considering similarity plus dissimilar values. So are we really calculating are we really interested in this dissimilar value? We are actually interested in this similar values, because here our intention is to find out the similarity between the two objects. So here this formula contains absence also, I mean dissimilar values also. We do not want that. So that is why let's go to the improvised formula, that is Jacob coefficient. Here this formula says that number of matching presences only divided by number of attributes. But remember, in this denominator now we do not consider the dissimilar values, that is 0 matches we do not consider in the denominator. Both in the numerator as well as in the denominator, we do not consider this absence or 0 value, right? So that means our formula is number of matching presences, means that is only one matching presences, that is similar values when x is equal to 1 and y is equal to 1, that is F11 only in the numerator, divided by number of attributes not involving 0. That means what? F00 is not included in denominator. So F01 plus F10 plus F11 only we are considering in the denominator. So our formula becomes now J is equal to F11 divided by F01 plus F10 plus F11. These are the two formulas now. So Jacob is more efficient compared to our SMC. And remember, in Jacob again this is why more efficient, because we are not considering here the absence, I mean not dissimilar values. We are not considering the dissimilar values, right? So here let's solve the problem. Okay, here in this problem we are trying to find out SMC and Jacob similarity coefficient we are trying to compute. So you can see here this is the question. X is equal to, you can see different values for X, and also for the object Y you can see the different values. And remember, all these are binary values only, correct? So both SMC and Jacob are used for similarity calculation of binary values, binary objects. You can see X has 10 values here, Y also has 10 values, right? So now let's see first, before calculating SMC and Jacob, we have to see what is F00, F01, F10 and F11. So you can see here Fxy in general. So this F00, what is F00 here? The count of values, that is the count of values where X is equal to, so right now I am checking for F00. So what is F00? When X is equal to 0 and Y is equal to 0, how many such values you have here? How many such coefficients you have here? The count of that only I want. So what is F00? See here if X is equal to 0, here also Y is equal to 0. So the count became 1. So F00 count is 1. Go to the next value. Again X is equal to 0, Y is equal to 0. Count became 2. Again here 0, 0. Count is 3. Again here 0, 0. Count is 4. Again here 0, 0. Count is 5. Again here 0, 0. Count is 6. And again here 0, 0. Count is 7. So F00 became how many? Total 7 values you have here where X is equal to 0 and Y is equal to 0. Similarly, now compute the other coefficients as well. What is F10 count? So X is equal to 1 and Y is equal to 0. So we have only 1. So F10, the count is only 1. What about F01? Do we have any? Yes, we have here 0, 1, count is 1. Again 0, 1, count is 2. Total count is F01, the count is 2. But do we have here anywhere F11? No, we do not have any count where X is equal to 1 and Y is equal to 1. That is why F11 is equal to 0. So you can see here F01 count is 2, F10 count is 1, and F00 count is 7, and finally F11 count is 0. Now when all these 4 values are available, we are ready to calculate the SMC. So SMC is equal to, the formula says F11 plus F00 divided by all, the sum of all attributes. So just substitute all these values, you get 0.7. And what is it indicating actually? 0.7 means 0.7 indicates that 70% similarity you have here between the two objects X and Y. Now we'll use for the same problem, we will just, same question, we will just use the Jacob formula to calculate the similarity. But remember, here we are considering only the similar values. Here F00 is totally discarded. So you can see F11. Do we have any F11 value? 0. Numerator itself became 0. So Jacob coefficient is equal to 0. So what is the inference of this? Jacob says that there is no similarity between the two objects X and Y. So can you see here X and Y? X has all these set of values and Y has all these set of values. At once when you see, you will come to know that X and Y are not matching. So you can say directly that X and Y are two dissimilar objects. But SMC says that there is 70% similarity between the two objects X and Y, right? Okay, so this is how you calculate and give the inference, right? Okay, next we will see the cosine similarity. So till now we have seen only for the two binary objects. Now we will see the similarity between the two objects X and Y, where the values of X and Y are not binary values. So we will call them now as the two documents. If I have to find out the similarity between two documents, where the first document is X and the second document is Y, in that case my SMC and Jacob will not be helpful here to calculate similarity. I must go for the cosine similarity. So cosine similarity, you can see the formula. Dot product between the two documents, you have to take two document objects X dot Y divided by determinant of X into determinant of Y. So what is this dot product? So the formula for the calculation of dot product is something like the summation of n values. So n values here, if I have x and y may have various values, right? So that is n values, and xk, the product of x and y values, the summation of that finally gives you the dot product. And this determinant of x and determinant of y indicates the length of x and length of y. We'll see the formula for that is again the square root of x square. So different values, all the values of x objects, x object, that is the object x will have several attribute values. So all those values, square of that, and take finally the square root of that. So that becomes x. Similarly, you also calculate y. So we'll just solve a problem on this, right? Okay, so even now the question is this. Okay, now just see here the two objects and see all the values are not binary values here. So x and y are two documents, and you can consider these values as, say, the count of words in each document. You can consider something like that. Okay, count of words in each document, right? Something like that. Now we'll just see the formula to calculate the cosine similarity here is the dot products of the two objects you have to take. So dot product, how do you take? The formula says here the dot product is summation of the product of x and y. So x1 y1 plus x2 y2 plus x3 y3. So it goes on up to n values, right? So x1 y1 x2 y2, so these are all the values. You just take the x dot product of them, right? And you get the answer here 5. Similarly, you can see what is the denominator. This becomes the numerator. Now the denominator is the length of x. Length of x is given by the square root of sum of squares of all these values of each object, right? So square root of 3 square plus 2 square plus 0 plus 5 square plus 0 plus 2 square. So the answer of that is 6.48. Similarly, you calculate the y also, length of y also. Now once you calculate all this, you substitute them in the given formula, and final answer what you get here, this cosine similarity is 0.31. And what is it trying to say? 31%, the two documents x and y are similar to 31%. So you can now that is actually how you calculate the two document objects. Now we'll just go to the next type of similarity calculation, that is correlation. Now we'll see what is correlation. The general meaning of correlation means what? Some relationship between the two objects, right? So now when you say correlation, the two objects may be binary objects or it may be continuous objects, okay, non-binary objects. So here we will have to calculate the correlation between, that is the relationship between two data objects x and y, say x and y, right? So now just see, if the two objects x and y has no relationship between them, that means there is no correlation between the two objects. Is it really worth to have those two objects in our data set, in our data warehouse? Not necessary, right? So the two objects, when they are not correlated, such objects need not maintain in our data warehouse. So that is why the correlation matters a lot. Correlation calculation has a lot of significance. So what do you mean by positive correlation and what is negative correlation? Here we will see. I'll give you a few examples to calculate the correlation, to understand this correlation, right? Okay. Yes, so see, we will take an example of height and weight, correct? Okay, so what is this height and weight? A person has, say, two attributes, height and weight. Let's say that as the person tends to grow, what happens? Height increases. As the height increases, let's start from childhood. As the height increases, definitely the person tends to be heavier also. The weight also increases. Yes, so height increases and the weight also increases. So can I say that the graph is increasing? there is an increase in the graph. So when height and weight are the two attributes of the person. So let me call this concept as positive correlation. There is relationship between height and weight. I hope you agree with this. So this is an example of positive correlation, because when one increases, the other attribute value also tend to increase. So such objects we need to retain in our data warehouse. What is negative correlation now? Negative correlation is something like, you can say, when one value increases, the other value decreases. Okay, so what is the example of that? Yes, let's take the example of students itself. If students do not attend class, that means what? The absences of students as it increases, what decreases? Automatically your results or the grade starts decreasing, right? So as you bunk more, that is, as your absences, as the number of absences increases, the grades that you score decreases gradually. So when one increases, the other value gradually decreases. And can I say that here there is no relationship? No, definitely no. There is relationship. That means as the number of your absence or your presence is definitely has a greater impact on the grades that you score, right? So there is relationship, but what type of relationship? This is negative correlation. So that is negative correlation. Why it is negative? Because when one value increases, the attribute value increases, the other one gradually decreases. You call this as negative correlation, right? And now one example for zero correlation. That means what? No correlation. Zero correlation means what? The impact of one doesn't, I mean, one object has no impact on the other object, or when the value, the increase or decrease of values of one object has no impact over the other. So what example we can give for this? One simple example let me give. That is, you watch TV, right? As you watch TV more, okay, more and more you watch TV, as it increases, whether it has any impact on the quantity of food that you have? No, definitely no. So as you watch TV more and more, the quantity of food that you have there doesn't decrease or also doesn't increase, right? That depends upon your capacity. So there, watching TV has no impact over the food that you consume. So this is something like the two objects which are not at all having relationship between them. Such objects do we have to maintain in our data warehouse when there is no correlation? No. So you have to now here consider, calculate or compute the correlation between the two data objects, right? So here we are using a formula to calculate this, that is Pearson's correlation coefficient formula. And here we are trying to compute correlation. If the answer that you get, the correlation after calculating, see here the range that we calculate, a correlation, you call that as the correlation values that you compute, that would be either 1, 0 or -1. You call that as perfect correlation. Perfect correlation will be always in the range of -1 to 1. So when the value of correlation is -1, you call it as negative correlation. When it is +1, it is positive correlation. And when it is exactly equal to 0, the meaning is there is no correlation, sorry. So here the range is always -1 to 1. You call that as perfect correlation. So now we'll just see the formula, Pearson's correlation coefficient formula. The formula is given by covariance between the two objects x and y divided by standard deviation of the object x into standard deviation of object y. We'll see now what is this formula to calculate the covariance between the two objects x and y. That is the numerator part. Covariance you calculate something like this. Summation of xk minus x bar into yk minus y bar. What is this xk and yk here? The two objects x and y, the values of the two objects x as well as y. So what is this x bar and y bar? It's nothing but the mean of all values of x, and this is the mean value of all the values of y, right? So n, what is n here? The total number of elements, the total number of values of your attribute of your object x and y. So the total number of values is given by n. So this is the formula to calculate your covariance. And then standard deviation. Standard deviation formula is what? Square root of 1 by n minus 1 into summation of xk minus x bar. This is mean again, this and again the whole square, right? Yes. So standard deviation of x and y you calculate, and finally whatever you calculate, finally you substitute in the above formula, right? Okay, now we'll just see here problems. See here, one problem is solved and the other two problems, one problem is solved, the first one, and the other two are given as homework. Unless and until you try out, you are not going to get hold on this, right? So definitely you may get stuck in the exam if you don't practice. So you must practice at home. The second and third one is given as a homework. Do it, please practice it. So the first one is, see, x, the problem is solved here, the value of x. So total how many elements you can see for x and y? Total there are 5 elements for each object x and y. So you can see here the values, the formula is given. Yes, the formula is covariance divided by standard deviation, product of standard deviations. So we'll start calculating the covariance. Yeah, so what is n here? N is the number of elements. How many elements we have? 5. So n is equal to 5. So mean you can calculate and keep it ready. Mean of x. So all these values you have to add up, divided by the total number of elements. Similarly, y also add all the values of y and divide by total number of values. So mean you calculate and keep it ready. So you can see the mean of x is 0, mean of y also is equal to 0. So when the mean value became 0, your formula became still more simpler, right? So you can substitute the values over here. Okay, so covariance you're calculating here something like this. The answer of this numerator, yeah, the numerator you're getting it as minus 7.5. Now what is remaining? Standard deviation, denominator part you have to calculate. So this is the standard deviation that you're calculating, Sx. Okay, so answer you get here 4.73. Sy also you have to calculate, standard deviation of y. Yes, so all these values whatever you're calculating now, yeah, all these values whatever you have calculated, you just substitute in the final formula. 7.5 was the covariance divided by standard deviation of x 4.73 into standard deviation of y 1.58. so the total the final answer you get it 1. So what is the correlation value equal to 1 means? The positive correlation is existing between the two objects x and y. That means when the x value increases, y value also increases. So that is positive correlation, perfect positive linear relationship between the two objects, right? So okay, so this is the this is what the correlation means. So that is what I'm asking you all to practice the second and third problem as well, wherein you get the answer of that one of the answer, I mean for one of the problem you get the answer as 0, and for the other problem you get the answer as 1 minus 1. So negative correlation, positive correlation and 0 correlation, all three problems are here. Yes, so one problem you may expect here from this section of in module 2, right? So right from your Euclidean distance dissimilarity calculation, you had three formulas: Euclidean distance, Manhattan, and finally supremum. Those three dissimilarity calculation. Okay, one problem you may expect there, and then after dissimilarity we moved on to similarity calculation. So wherein we saw the formula to calculate the similarity. One is simple matching coefficient SMC, and then Jacob coefficient. Those are the two formula for calculating similarity between the binary values. And then we moved on to cosine similarity, where the two objects are document type of objects, that is not binary values, right? And then we moved on to
correlation concept after cosine similarity. So correlation is the one wherein you are finding the relationship between the two objects. So it may be binary values or they may have continuous values, doesn't matter. So correlation, again, you have three types of correlation values, that is zero correlation, no correlation, or -1 negative correlation, and +1 that is positive correlation, right? So correlation is the final one. So there also you may expect a problem. So all these are the problems that you have in module 2. So I hope you all understood this. Now it's your turn now to practice all these problems. I hope you all have solved your assignments as well. Okay, so practice all the problems.